a glacier-clad mountain in British Columbia has started breathing. Not smoke, not an ash cloud, but three enormous holes melted clean through a solid mantle of ice, each 30 meters wide. On July 21, 2016, a helicopter pilot flying over the remote peak saw them by pure chance, three gaping wounds in the Job Glacier, venting gas from deep within the earth. The air around them smelled of rotten eggs, a telltale sign of lethal hydrogen sulfide. Scientists now understand this was a new signal from deep underground, a message from a magmatic system that was supposed to be sleeping. But here is the detail that tells the real story. This volcano, Mount Meager, is not just waking up, it is rotting. For thousands of years, hot acidic gases have been dissolving its internal structure, turning solid rock into weak, unstable clay. And the most immediate danger is not that the volcano will erupt, it is that the mountain itself will simply come apart. To understand the threat, you have to understand the mountain. Mount Meager, known as elqw elústen to the Líl nation on whose land it sits, is a colossal stratovolcano at the far northern end of the Cascade Volcanic Arc. This is the same geological system that fuels Mount St. Helens and Mount Rainier. And just like its American cousins, Meager has a violent history. Roughly 2,400 years ago, in approximately 400 BCE, it produced the single most violent explosive eruption in Canada's last 10,000 years. Geologists rate the event as a volcanic explosivity index of 4 or 5, making it comparable in power to the 1980 eruption of Mount St. Helens. It fired a column of ash high into the atmosphere, which fell as far away as modern-day Alberta. It sent pyroclastic flows, superheated avalanches of gas and rock, screaming down its flanks. And the Líl nation remembers. Their ancient oral histories contain precise, astonishingly accurate accounts of the event, describing the mountain unzipping, the sun being blotted out by ash, and immense floods scouring the valleys clean. For centuries, these were stories. Today, geologists mapping the rock layers have confirmed every detail. The stories were a warning. This is the part that Canada has been slow to acknowledge. While the United States has poured resources into a gold standard network of sensors on its Cascade volcanoes, Canada's have remained largely unmonitored. The assumption was that they were dormant, quiet, locked under ice in a remote corner of the coast mountains. Mount Meager was seen less as a threat and more as an alpine playground. Luxury helicopter tour operators would land on its glaciers. One group even carved a tequila bar into the ice for a catered party, complete with a DJ, on the flank of what we now know as the country's highest threat volcano. The 2016 discovery of those toxic fumaroles changed everything. It was a wake-up call, forcing a reassessment that culminated in a 2024 Canadian government study. That report officially ranked Mount Meager as a very high threat, the highest possible rating. And it did so for two terrifying reasons. The first is that the mountain is falling down on its own. Dr. Glyn Williams-Jones, a volcanologist at Simon Fraser University and the country's leading expert on Meager, has a simple, chilling description for the mountain. It's rotten. Imagine a constant stream of sulfuric acid percolating through a block of concrete for millennia. The acid doesn't just stain it. It dissolves the chemical bonds holding it together, turning solid aggregate into mush. This is what has been happening inside Mount Meager. Hot hydrothermal gases rich in sulfur have been seeping through the volcanic rock, altering its chemistry, turning feldspars and volcanic glass into weak, slippery clay minerals. For thousands of years, this structural decay was held in check by one thing: massive glaciers pressing in on the mountain's flanks like a natural brace, literally holding the rotten rock together. Now, that brace is melting. As climate change accelerates glacial retreat across the globe, Mount Meager is being exposed. The ice is thinning and pulling back, removing the immense pressure that provided its structural integrity. The rotten mountain is beginning to slump under its own weight. We already know what this looks like. On August 6, 2010, at 3:27 in the morning, the south face of Capricorn Peak, one of the sub-peaks on the Meager Massif, failed. Without any warning, without any eruption, approximately 50 million cubic meters of rock, ice, and mud broke free and collapsed into the valley below. It was the largest landslide in Canadian history. The debris avalanche traveled 13 kilometers downstream, damming the Lillooet River for nearly a day. When the dam finally broke, it released a surge of water that caused what Dr. Williams-Jones later described as biblical-level flooding. Water cut through 2.5 kilometers of solid rock in just 8 hours. This is the kind of geological event we just don't think about in modern timescales. And it was just a preview. The 2010 landslide was a collapse without an eruption. The far greater risk is a collapse triggered by an eruption, which brings us to the second, deeper threat, the heat source that is melting those holes in the ice. After the helicopter pilot's discovery in 2016, scientists scrambled to understand what was happening on the Job Glacier. Dr. Williams-Jones and his colleague from the University of British Columbia, Dr. Kelly Russell, flew to the site. What they found confirmed their fears. The vents, or fumaroles, were belching out lethal concentrations of hydrogen sulfide and carbon dioxide. The gases were so toxic and dense that they pooled in the bottom of the newly formed ice caves. As National Geographic explorer Christian Stenner, who would later lead an expedition into them, put it, if a climber capable enough to climb up there went all the way into a crevasse, they would drop dead. These were not just passive steam vents. This was direct evidence of a live, volatile magmatic system deep underground flexing its muscles. The patient was not extinct. And as Dr. Williams-Jones noted, if we're not looking, we can't take the pulse. We can't say, is the patient awake or not? For years, Canada wasn't looking. It's an interesting thought, the idea of a mountain literally dissolving itself from within. I'm actually curious what you think about it. Let me know down in the comments. This internal decay is a slow, quiet process, but the results can be catastrophic and sudden. In the summer of 2022, Christian Stenner and a team of explorers, funded by the Trebek Initiative and the National Geographic Society, did what seemed impossible. They decided to go inside. Their mission was to descend into the glacio-volcanic caves under the Job Glacier, collect direct gas samples, and search for extremophile life thriving in the toxic environment. The expedition was unbelievably hazardous. The caves were unstable, constantly shifting as the glacier moved and the volcanic heat melted them from below. To even access the main chamber, Stenner had to anchor ropes to the ice, put on a full respirator with compressed air, and swing like a pendulum across a 7-meter-wide pitch-black chasm. Below him was a subterranean abyss where a fatal concentration of hydrogen sulfide gas had pooled. To breathe that air for more than a few moments would mean suffocation. The team successfully sampled the gases gurgling up from the vents. The analysis confirmed a magmatic signature. The heat and the poison were coming from the same deep source that powered the Great Eruption 2,400 years ago. The volcano wasn't just degassing old residue, it was clearing its throat. This confirmation elevates the threat exponentially. It presents a terrifying dual risk scenario. The increasing heat from below is melting the Job Glacier from the bottom up, while climate change melts it from the top down. The glacier contains an estimated 75 million cubic meters of ice. If an eruption were to happen under that ice sheet, it would melt almost instantaneously. The result would be a lahar. A lahar is not a water flood. It's a fast-moving, concrete-like slurry of mud, boulders, and debris that can travel at highway speeds, scouring entire valleys and burying everything in its path. For Mount Meager, the path leads directly down the Lillooet River Valley. 65 kilometers downstream, nestled in that valley, is the town of Pemberton. Researchers at the University of British Columbia, led by volcanologist Dr. James Kelly Russell, have spent years modeling this exact scenario. The simulations are grim. A large-scale lahar originating from Mount Meager would give communities like Pemberton mere minutes of warning before it arrives. The force would be unimaginable, capable of destroying bridges, highways, and sweeping away entire neighborhoods. The Squamish-Lillooet Regional District, the local government authority, has emergency plans in place, evacuation routes to high ground, alert systems, but the speed and scale of a Meager-generated lahar pushes the limits of any modern emergency response. It's a threat that hangs over the region, growing more plausible with every new signal from the mountain. And signals are appearing. Beyond the fumaroles, recent satellite data has shown something else. Using a technique called INSAR, which can detect minute changes in ground elevation from space, scientists have observed the flanks of Mount Meager beginning to bulge. The ground is deforming, swelling upwards. This is a classic indicator that something is moving deep underground. It could be magma intruding into the crust, or it could be the pressurization of superheated hydrothermal fluids. Either way, it means the system is active, dynamic, and building pressure. This physical swelling of the mountain, combined with its known structural rot and the melting of its glacial brace, is a recipe for catastrophic failure. The 2010 landslide, as immense as it was, may have been just a foreshock. This is the context for the desperate race now underway. For years, Scientists like Dr. Williams-Jones have been sounding the alarm about the monitoring gap at Canada's volcanoes. While Mount St. Helens is wired with a dense network of seismometers, GPS receivers, gas sniffers, and cameras that provide a constant real-time health check, Mount Meager has been comparatively blind. After the 2024 Very High Threat Assessment, the urgency finally broke through. In November 2025, plans were announced to finally install a proper modern monitoring station on the volcano. The installation, scheduled for the spring of 2026, is being championed by Williams-Jones and funded in part by the local Pemberton Diking District, the very community most at risk. If you find these kinds of deep dives into hidden geology and unfolding natural events interesting, you can subscribe for more. We cover stories like this that you won't see in the headlines all the time. The new station represents the gold standard for volcanic monitoring. It will include a seismometer to detect the subtle earthquakes caused by moving magma, high-precision GPS to track ground deformation like the bulging seen from space, cameras to watch for physical changes, and infrasound sensors that can detect explosions and avalanches that are too low frequency for the human ear to hear. For the first time, scientists will be able to take the volcano's pulse in real time. The data will stream continuously, creating a baseline of the mountain's normal behavior. Any deviation from that baseline, an increase in seismic tremors, a sudden acceleration in ground swelling, a change in gas composition, could provide the first precious minutes or hours of warning that something is about to happen. It is an attempt to finally put eyes on a threat that has been ignored for decades. But what if the next event isn't an eruption? What if it's another landslide, only bigger? The 2010 collapse released 50 million cubic meters of debris. But geologists have identified other unstable blocks on the massif that are many times larger. As the glaciers continue to recede, the probability of one of these blocks failing increases every year. Such a collapse could be even more devastating than an eruption-triggered lahar. It could create a landslide dam on the Lillooet River far larger than the one in 2010, holding back a massive lake that, upon failing, would unleash an unimaginable flood on Pemberton and the valleys all the way to the coast. This is the unique, terrifying nature of Mount Meager. Dr. Williams-Jones summarized it perfectly. The big issue with Meager is landslides, but landslides off an active though dormant volcano. We have gas coming out, so we can't say it's extinct. This dual threat, collapse and eruption, puts Pemberton in a uniquely precarious position. If you've ever seen footage from the 1985 Nevado del Ruiz eruption in Colombia, you understand the power of a lahar. A relatively small eruption melted that volcano's ice cap, sending a mudflow that buried the town of Armoro and killed over 23,000 people. Mount Meager has vastly more ice, and its explosive potential is known to be significant. A detailed explanation of the flow dynamics shows why the risk is so high. When the superheated rock and gas of a pyroclastic flow hits the 75 million cubic meters of ice on the Job Glacier, the transfer of heat is almost instantaneous. The meltwater mixes with the loose, hydrothermally altered rock and clay on the volcano's slopes, creating a dense, non-Newtonian fluid. It doesn't flow like water. It moves like a wave of wet concrete, carrying boulders the size of houses. It would follow the path of least resistance, the Capricorn Creek and Meager Creek drainages, funneling directly into the Lillooet River. The models show it reaching Pemberton in under an hour. Anything in its direct path would be obliterated. If you found that explanation of the lahar threat useful, a simple like on the video helps more people understand the risks. You could even low-key send this to a friend who lives on the West Coast, just so they're aware of the geology in their backyard. Anyway, back to the story. There's another twist to this story, a paradox buried deep underground. The same intense geothermal heat that makes Mount Meager a ticking time bomb also makes it one of Canada's most promising sources of clean energy. The very thing that threatens to destroy communities could one day power them. Recent techno-economic analyses published in late 2025 have highlighted the immense potential for enhanced geothermal systems, or EGS, at the volcano. An EGS power plant works by drilling deep into the hot rock, injecting water to fracture the rock, and then bringing the superheated steam back to the surface to spin a turbine. Scientists like Dr. Stephen Grasby from the Geological Survey of Canada have been leading expeditions to evaluate this potential. They estimate the deep underground system has a fluid production rate high enough that a single geothermal plant at Meager could provide stable baseload power for hundreds of thousands of homes in Western Canada. It is a literal balancing act of power versus peril. The drilling and exploration for this energy source also provides a valuable secondary benefit. It helps scientists better understand the plumbing of the volcano itself. Each hole drilled is another window into the deep, hot, and dangerous world beneath the ice. This brings us back to the present moment. The rotten mountain sits under a melting crown of ice. The ground beneath it is swelling. Toxic gases are seeping from its glacier, a constant, quiet reminder of the pressure building below. And two competing human endeavors are now focused on it. One team racing to install sensors to warn of its next deadly move, and another team drilling into its flank, hoping to harness its power for good. The ancient name, elústen, is a powerful echo from a past that seems determined to repeat itself. The people who gave it that name knew its nature. They watched it happen before and passed the story down, ensuring the knowledge would not be lost. For a time in the modern era, that knowledge was forgotten, dismissed in favor of a comfortable belief that the past was the past. It's a stark contrast with Canada's other infamous volcano, the Tsiaks Cone, sometimes called the Ayanch volcano. Tsiaks Cone holds the tragic record of being its deadliest. In the 18th century, its eruption didn't produce a massive explosion, but effusive lava flows and, critically, a huge release of volcanic gas, likely carbon dioxide. This dense, invisible gas flowed down the valley and settled in the low-lying villages of the Nisga'a people, asphyxiating an estimated 2,000 men, women, and children in their sleep. It was a silent killer. Mount Meager presents a different, more complex, and arguably greater modern threat. It combines the explosive fury of a St. Helens, the collapse risk of a mountain rotting from within, and the lahar potential that has proven so devastating elsewhere in the world. And unlike the Tsiaks event, its fallout would not be confined to a remote valley. An ash cloud from a major VEI, 5 eruption at Meager, could disrupt air travel across North America for weeks, clog infrastructure, and impact agriculture hundreds of kilometers. The threat is not just local, it's continental. So as spring 2026 arrives, a team will fly to a carefully selected spot on the flank of Mount Meager. They will drill into the rock and install the first instruments of a permanent watchful eye. They will be bolting a fire alarm onto a weapon that is already